Welcome to HashiCorp Digital 2020. My name is Thomas Lefebvre, and today I'm going to be talking about how we use Nomad and Consul at Cloudflare. So first, a quick introduction about me. So I've been an SRE at Cloudflare for a bit over 4 years. I'm currently part of the Edge platform team at Cloudflare. So my role as an SRE is first to ensure the reliability of all the production software which is running at the edge, and also working on automation projects such as provisioning automation, release management automation, and also more recently task scheduling, which is what I'm going to be covering today during this talk. So next I'm going to be talking about Cloudflare. So we've got a pretty massive network. We have hardware deployed in 200 cities, and that list of cities keeps growing every week and every month. So our strategy when deploying new locations is to be as close as possible to our customers who are using our services such as CDN, Cloudflare Workers, DDoS protection, and web application firewall, for instance. So we're trying to be within 100 milliseconds of every website visitor or internet user globally. So during this talk, I'm going to be covering our use case for deploying Nomad to Cloudflare's Edge, and also how Nomad interacts with Consul as part of this deployment. So first, some history. So as I said, we have 200 plus locations. We have servers, physical servers in each of those locations. Some deployments are smaller than others. Some are pretty large, especially in big metros. But what's common between those locations is that all servers run all software. So it was a design choice that was made pretty early at Cloudflare, and it makes it super easy to scale horizontally when and as we get more traffic. We just need to keep adding more servers to existing locations to keep scaling with the increasing amount of traffic that we receive. So from an architectural perspective, it makes it super easy. But recently, we've had internal asks within the company for more on-demand workloads. For instance, as you can see in this graph, we have time during the day where CPU is pretty underused, and we could use that available CPU during those off-peak times. And also, so I've been covering mostly customer-facing services, Cloudflare products, which scale horizontally with the number of machines we keep adding. But in each of those locations, we have management services, for instance, monitoring, configuration management. And those services, because they're not customer-facing, we don't need to scale them at the same speed as customer-facing services. They don't need to run on all the machines. So when deploying new services to the edge, we have two options. The first one, as I said, running those services on all machines. So the pro is that it's super easy to scale, as I mentioned before. But the cons is that it uses more resources than it potentially needs, especially for those management services. And as you keep collocating services together on the same machines and you keep adding more and more, you're at risk of some of the services using more CPU than they should, or more memory, and so their footprint keeps growing and growing, and you're at risk of having noisy neighbor scenario where some services are impacting others, which is not what we want. So the alternative to that is to pick a static list of machines in each data center and choose them to run the services which don't need to run everywhere. So it's less wasteful of resources because you don't have that big of a footprint in terms of CPU and memory anymore. But the con of that is that when you have hardware failures, which happen every day when you have a few thousands of machines or more. And so you kind of have to get each engineering team who are deploying their software to be aware of that really complex architecture, which can be different from colo to colo, from deployment to deployment. And they have to engineer a reliability strategy working around those constraints. So all that led us to believe there had to be a better option that we could propose to our engineering teams at Cloudflare to deploy their software. And so that's where we decided to add a new layer so that teams are able to use dynamic task scheduling to schedule a service in each data center without having to know what's the architecture of the data center, like how many machines there are, etc. We just give them for free. They want their service to be running at all times in the data center, and that's the value we're trying to give to those teams. So another objective of that is that it provides us with a unique place to add resource isolation. So I was talking about noisy neighbors earlier, and having that layer of task scheduling, we can add constraints to avoid collocating certain services together. We can set resources limits, and we can even add security layer, which becomes then the default of all services using that new layer of dynamic task scheduling. So that gives us improved reliability to hardware failures, because dynamic task scheduling, if there's a service running on a machine and that machine goes down for any reason, it's just going to get rescheduled to another machine and it's going to stay online. Additionally, the service, because you don't need to provide extra reliability by running it in more places than you need, it only uses the resources that it needs at any point in time. And finally, the last objective we had when designing that new solution was that the operational cost of the new system we were deploying to fit those needs, it had to be as minimal as possible. Because the goal is to save time for all the product teams deploying their services, but we don't want to be at the expense of the SRE team who has to spend all that time managing that new software. So while looking for that new solution, we looked at different software, and we ended up picking HashiCorp Nomad because it satisfied our initial requirement, which was we had this management service which we wanted to run in every data center reliably, and Nomad completely fit that need. And also additionally, because it's lightweight and reasonably simple, its operational cost is not as large as some competing solutions. It also has very few dependencies, the main one being Consul, which we already had deployed in every location for a different use case. So it was really easy to pair those two HashiCorp solutions together. So now I'm going to be talking about the design of our Nomad implementation at Cloudflare, how we deployed it, how we manage the deployment, etc. So first, the cluster architecture. So as I mentioned, we have around 200 locations where we have servers. And one important thing about those locations is we want them to be separate from each other. We want them to be part of different failure domains. We don't want a failure in, let's say, Amsterdam impacting the London location. So with that in mind, we deployed a different Consul cluster in each of those locations. so that a failure of a Consul cluster or anything else wouldn't impact other locations. And therefore, we also deployed separate Nomad server cluster in each location. And so the way we make it reliable, because now the reliability burden is placed on that new layer, which is Nomad server. So we pick machines in different failure domains, such as machines connected to different switches, machines in different racks, and even machines in different physical sites, just to ensure that one rack going down wouldn't bring the Nomad server cluster down, which would in turn cause an outage for services trying to schedule on top of Nomad. And the Nomad client part, which is responsible for running all the jobs, we simply run it on all machines and let Nomad make scheduling decisions when placing those tasks to each of those machines. So now I'm going to cover how we manage the life cycle of the Nomad server cluster, how we bootstrap and deploy it, and also how we manage upgrades for it. So first, one of the requirements when deploying a new service, we don't want to have to make any manual task or intervention when we deploy new data centers or when we expand existing data centers. So all the edge machines are supposed to be stateless, which means we can wipe them, reboot them, and they should all come up cleanly in production without requiring any manual intervention. So with that in mind, to simply bootstrap a new Nomad server cluster in each data center, as we add new data centers to our fleet, we use the Consul cluster, which is bootstrapped by orchestration. So we use salt stack. When machines come up, they pixie boot a very minimal image, and then salt stack goes and manages the formatting of this, deploying software, etc., including deploying the Consul cluster, and then also deploying the Nomad server cluster, which is relying on the Consul cluster being present to automatically cluster nodes. They advertise themselves to the Consul cluster, and once we hit the correct number of instances we expect, as set by the bootstrap expect parameter in Nomad server configuration, the Nomad server is then ready to go without any manual intervention needed. Part of the lifecycle of the Nomad server clusters that we have deployed in all those locations is upgrading the Nomad version, just to stay on top of all the new features which are getting released every month, or even more frequently sometimes. So as I said, we drive the Nomad deployment using our orchestration framework that we use, which is Salt, and it runs periodically on all machines. But then, because we have physical machines, it's not as if we could spin up a new VM and with a new version of Nomad server running on top of it and then stop the old VMs. We have to update and upgrade Nomad server in place. And also an additional requirement is that we want to do all of this with zero downtime, because we don't want to have to disable a location to upgrade a version of the software, so everything has to happen live. So we achieve that using, once again, Consul. So we have orchestration to avoid restarting multiple Nomad server instances at the same time, which could cause losing quorum. We have it hold a lock in Consul during the upgrade process, so that if orchestration runs on another node running Nomad server in the data center and tries to hold that lock, it's going to have to wait for the upgrade to be finished. So in a sense, we only upgrade one instance of Nomad server at a time ensuring continuity of services of service of Nomad server. And additionally, to get the Nomad server instance to leave the cluster gracefully when we stop it before upgrade, we use the leave on interrupt option so that it tells the other members of the cluster that it's leaving the cluster when it gets a SYN interrupt. Just to save a bit of time and also to add some additional reliability to the Nomad server cluster. So now I'm going to cover the Nomad jobs provisioning part. So I went over how we deploy the Nomad server cluster and how we upgrade it, but now it's time to add some jobs and start using the actual cluster. So the way we see it, there is a shared ownership of the whole platform, and each team owns a different layer of that platform. So we as SRE, we own the Nomad cluster, deploying it, making sure that it's reliable. And product teams, they own the software which runs on top of the platform. But then there is kind of a layer in between those two layers, which is how those product teams can interact with the Nomad cluster and how they get really good observability of all the software that they run on top of Nomad, which is really important, just to give them a sense of ownership of those products, and they can manage the whole life cycle. So first, provisioning new jobs and also managing those jobs in production. So we use a Git-based workflow where teams commit their HCL job files to a Git repo, then a Debian package gets built by CI, and then deployed to the edge data centers in stages. So we deployed those in stages just to make sure that a typo, or not even a typo, but just a bad version of a particular Nomad job is not going to break the entire edge at the same time. So when that Debian package is built and rolled out to the edge by orchestration running periodically, orchestration also runs Nomad job run and Nomad job plan before running Nomad job run to detect that there were some changes in the Nomad jobs and to ensure that they're always in the correct state in the Nomad cluster. So we'd like to improve the turnaround time of those job deployment in the future, and also to give a bit more immediate control to product teams on those jobs when deploying them and rolling them back. And so we're looking at having CI pushing jobs directly to the edge and to each Nomad cluster inside the edge, perhaps using Terraform. And so the goal would be to also keep that level of safety when rolling out Nomad jobs to stages, to small canary deployments, to small percentage of the fleet before going global. So we'd have to work on implementing that same logic in that CI deployment workflow. So now we have our jobs deployed on top of Nomad. So the next thing we want to have is good observability on those jobs. So when jobs are being deployed to Nomad, and when the jobs write to standard out and standard error, we have a custom test driver, which also has other tasks and duties, specifically adding another isolation layer between Nomad tasks running at the edge. But also what it's doing is that it's just forwarding logs, which are being written to standard out and standard error to the local syslog server running on each machine in every data center. And then the local syslog ships those logs to a central syslog server we have in our core data centers, and they became indexed in Elasticsearch, and teams can see in real time in Kibana logs for their services running on top of Nomad. So it gives them feedback on what's happening for those jobs, which is really important. What's also important and what we get for free when using Nomad is that by enabling Nomad metrics, you get a lot of insight from the job status, the summary. You can also look at C groups and see how much CPU and memory jobs are using. So you kind of get those metrics for free, but when teams want service-specific metrics, we also set up something to dynamically scrape the metrics endpoint of each service. And the way that works, once again, leveraging Consul, when services run on top of Nomad, they are advertised in the Consul service directory. And when the services in their Nomad job file, they add a tag, which is enable Prometheus scraping in our case, that instructs Prometheus to start scraping metrics for this Nomad service. So Prometheus uses the Consul SD, so it queries the Consul service directory in each colo and looks for those Nomad metrics endpoints which are matching the enable Prometheus scraping tag. And so once those service-specific metrics are in Prometheus, each team can then create Grafana dashboard for those service-specific metrics and also set up alerting on those jobs and get alerted as soon as something goes wrong on their Nomad service without any involvement needed on our end. So the goal really is to give good reliability for services to product teams and also to give them good control over the life cycle of their services, releasing a new version, looking at logs, seeing metrics, alerts, etc. So in conclusion, so we have quite a few workloads running on top of Nomad now. It's still pretty early stage. I think it's been 6 months now since the clusters have been deployed, but we're seeing new workloads being added to Nomad every quarter. Some of those workloads, they're legacy workloads, I'd say, which we used to run on a fixed set of machines, and that we're now migrating to Nomad to have this extra level of reliability. But we were also really happy to see that it gave some ideas to product teams or other teams at Cloudflare, and they're taking advantage of this new dynamic scheduling capability in every colo to deploy their services. A recent example that was announced on the public blog of Cloudflare is cron triggers for Cloudflare workers. So the service which schedules on a timer workers to run, this service is running on top of Nomad, so it was really exciting to see. And we expect more and more things to be added, which gives us a nice challenge as SRE, because as you deploy more things and as it gets more and more critical, you encounter lots of interesting things to work on to make sure the Nomad server cluster is as reliable as ever and also as well maintained as possible.